This is ChemQuest 34% Yield by Marco Rodella. Alright. Information. If we react 23 grams of sodium metal with plenty of chlorine gas, calculation tells that we should get about 58.5 grams of sodium chloride. However, if you tried this in the lab and then took the mass of your final product on a balance, you would usually get somewhat less than 58.5 grams. The more careful you are, the closer you can get to the mark of 58.5 grams, but you will never be able to make 58.5 grams of sodium chloride. Critical thinking questions. What are some practical things or some sources of error that can happen in the lab and in a reaction that would cause us to get less than 100% of the product that we're trying to produce? Well, spilling some of the product before weighing it, or evaporation of some of the product that is a liquid, can cause us to lose some mass from the product that we're trying to use here. So yeah, okay. Question number 2. The information section above made it sound like we always would get less than 58.5 grams of salt. However, it is possible that after the reaction we could take the mass of the product and find that it is greater than 58.5 grams. According to our calculations, this should be impossible, but what sources of error may cause this? Well, contamination of the product with a substance that adds weight could affect this. So let's say like dust from like the air or something, or like a piece of your hair would fall into the substance that could cause it to increase in mass when you weigh it. Alright. Question number 3. When 40.5 grams of sodium metal reacts with plenty of chlorine gas, how many grams of sodium chloride should be produced? So first you multiply by the initial 40.5 grams of sodium. You multiply that by the molar mass of sodium, which is 1 mole over 23 grams of sodium. You then multiply that by the multimole ratio between sodium and sodium chloride, which is 2 moles of sodium chloride per 2 moles of sodium. Then you multiply that by the molar mass of sodium chloride, which is 58.5 grams per mole, to get the final mass of sodium chloride, which is 103 grams. Okay, next. More information. Percent yield is a measure of how much of a product you actually obtain in a reaction compared to the amount that you could have obtained according to calculations. So percent yield equals actual yield over theoretical yield times 100. Theoretical yield is the amount of the product that we should be able to make. Okay. Question 4. Consider the combustion of 215 grams of butane with plenty of oxygen. If you are able to collect 295.3 grams of water in the laboratory, what was your percent yield? Hint. First calculate your theoretical yield using the balanced equation and mole ratios. So, once you figure out the balanced equation, then you go ahead and multiply by the initial concentration of butane, which is 215 grams. You multiply that by the molar mass of butane, which is 1 mole over 58.12 grams of butane. You multiply that by the multimole ratio between water and the butane, which is 10 moles of water per 2 moles of butane. Then you multiply that by the molar mass of water to get the final mass of water, which would be 33.2 grams of water. To find the percent yield, you plug that into our equation that we just went over. So you plug in the actual yield, which is the 295.3 grams of water, over the theoretical yield, which is 333.2 grams of water, times 100 to get the percent yield of 88.6%. Okay, question number 5. Consider the double replacement reaction of excess sodium chloride with 203.9 grams of silver nitrate. If you are able to produce 150.4 grams of silver chloride, what was your percent yield? So first we write the balanced equation.